As it was discussed in the old video that we were about to put the mole fractions of the different components. So for example, if I put the mole fraction of methane to be 0.8, so a new window has appeared in front of me. On your right side you can see that you will be having different composition basis. It can be either on the mole fractions, mass fraction, liquid volume fraction, mole flows, mass flows, liquid volumetric flows. And then in the down you will having a erase button through which you can clear all the mole fractions or the other stuff that you want to erase. And then you can equalize the composition. For example, if you have an equal composition in the material stream, for example all of them are 0.1, so you'll just put 1.1 in the methane and you'll say equalize the composition, and it will equalize the whole mole fraction composition. Then comes the normalize. For example, if you just give 0.8 and 0.2, for example I give 0.2 in the ethane, so I just press normalize. So for the remaining components it will generate itself by 0. So you'll press OK. So when I press OK, you have seen that the color has changed to the green from yellow, which shows that this material stream has been converged. This material stream has been converged, and now we can see that in the simulation area, if you see, this one was light blue before when the material stream was not converged, and now it has turned blue, dark blue. And you have seen in the messages corner there are no messages that is showing that there is no error in this material stream. So this is how you converge the material stream in the simulation area. Another thing that you might have to understand is that you have the unit sets here, so you can select the unit from here based on the different properties that what you want to have it. Another option, built-in option inside the Aspen Hysys is that you can use the field SI, Euro SI, or the new user. If you go to the new user will be your own set of the units that you will set for every single property that we are having over there. So you set your preferences. I haven't set anything, I've just put it on the SI. So I'll just press OK and we'll go back to the simulation area. So this is how one of the material stream is simulated. This material stream, once it is simulated, and you'll get to know about these equipments that you can use, or the system or the process that you are having, so you can add it up. So I'll just give you a small little brief view of this one. So the first one that on which my cursor is, that is the mixer. The mixer is the component in which different material streams are coming together, and they are merging over there and intermingling with they become in they combine together over there and then goes as a single stream. Then comes a T or splitter. In the new Aspen version 10 it is known as the splitter. In the splitter or the T, you have one stream and you then segregate the flow into the different ratios, whether it can be 50-50 depending on if you are having two streams, whether it can be 33% based on the 3 streams, 4 streams. It depends how much molar flow or the mass flow that you are going to define it for the T. Okay, the next thing is that the most important thing over here will be the energy stream. So for example, if I am having this material stream and if I am going for the pump, and if I add a pump over here, I just drag the pump from there, and if you go and open the pump, and you'll give the inlet and the outlet. Inlet is 1, and for example if I consider outlet to be 1, then there will be an energy stream that is known as the red, if you can see on the picture. So this is your material stream coming in, and this is your material stream going out. This is your energy stream. So I just click it and it is showing some error. If you see in the bottom picture, in the bottom here, it is saying that vapors are in the inlet stream, which means that your pump will be having the cavitation effect.